Okay, so our topic is cylindrical shells, and it allows you to find the volume of any problem as dx rather than dy. The formula is volume equals 2 pi times the integral from a to b of the radius times the height. A and b are usually given in the problem. A is where the function starts, and b, like, it actually generally just tells you in the problem. The radius is generally x, except when the problem is being revolved by around an axis other than y equals 0. And when that happens, the radius, like the equation of the radius changes. So if the axis of revolution is shifted to the right, so x equals positive whatever number, so x is greater than 0, the equation of the radius is the equation of the line x equals whatever minus x, and if x is shifted over to the left so that the axis of revolution is negative, then the equation of the radius is x plus the equation of the line. And actually it's not the equation of the line, it's x, it would be x plus the absolute value of the equation of the line. The height is always the function, except when you're finding the volume between two curves, so that would make the equation, the height equation, the upper function minus the lower function.
Okay, we're going to do two example problems. Let's get rid of this. Function. So our first problem is bounded by the functions y equals negative x squared plus 4x plus 3. And we also have the vertical lines y equals 0, x equals 0, x equals 4, and the horizontal line y equals 0. So I'm going to start by drawing the graph of the function. So we're only concerned with the first quadrant since we have the x equals 0, y equals 0. And we have the vertical line x equals 4. And our function x squared plus 4x plus 3. So that looks something like this. And if we were to revolve that all the way around the, and this problem is revolved around the y-axis. So if we were to revolve that around the y-axis, it looks something like this. So we start by finding our radius. And since this is around the y-axis, our radius is just equal to 0, or to x. And then the next step is to find the height. And this would be our upper function minus our lower function, so we would have our orange function negative x squared plus 4x plus 3. And since the lower function in this case is y equals 0, it would just be minus 0. So now we just plug that into our formula. So we have our volume is equal to 2 pi and times the integral from 0, and in this case our upper bound is 4 because we have the vertical line of 4. So from 0 to 4, and then of our radius, which is x, times our height, which is just our function negative x squared plus 4x plus 3, and then dx. And you just plug that in your calculator and solve, and you get a value of 272 pi over 3. So for our second example, we have our graph bounded by y equals x squared, and y equals 8 minus x squared. And this is also bounded by the first quadrant, so it would be the lines y equals 0 and x equals 0. So once again, we start by drawing the graph. And we're only interested in the first quadrant. So we have our line, our function x squared looks something like that, and 8 minus x squared, something like that. And in this function, or for this area, we're revolving it around, or volume, I'm sorry, we're revolving it around x equals 2. So now, just like the last problem, we find the height, or the radius, and our radius is equal to, in this case, 2 minus x, because we're revolving around x equals 2. And the height is your upper function minus your lower function, so 8 minus x, or 8 minus x squared, and then minus x squared. And now we just plug that into our equation. So your volume equals 2 pi times your integral from 0 to 2, because that is where these intersect. And then times your radius, which is 2 minus x, and then your height, 8 minus x squared dx. And then you put that in your calculator and solve it, you find that your volume equals 80 pi, 80 pi over 3.